Hello, everyone. Good morning, good afternoon, or good evening, depending on what time you're watching this video. It's me again, Teacher Kent. And today, we're going to learn more about the different types of rocks. Now, I know you already know about the three types of rocks. Remember, we have igneous rocks. We also have sedimentary rocks. And finally, we have the third type, which is the metamorphic rocks. Now, let's learn more about each type of rock. Let's learn what are the types of rocks called. Let's start first with igneous. Now, we know that igneous has two types of rock, right? We have intensive igneous rock or extensive igneous rock, which basically means the igneous rock is inside the ground or outside the ground. Let's find out, shall we? We have a website. There you go. We have a website about igneous rocks. All of these in the pictures, they are examples of igneous rocks. And if you look at them closely, they have different colors, they have different shapes. But how do we know which of them are igneous rocks? Let's go down a bit, shall we? Let's start here with this, in this section. This rock. This is an igneous rock. What type of rock do you think this is? This is a granite pegmatite. Granite pegmatite. This rock formed in the crust near the top of a crystallizing magma chamber. It is composed of the minerals quartz, orthoclase, albite, and mica. The larger crystals grew more slowly than the smaller crystals. Now, this granite pegmatite right here in this photo, it's actually formed near an area where there is a lot of magma. It's not really an area where the magma is right there, but it's outside, but it's still inside the earth. Like, for example, let's say this is the area that has a magma. This rock, this granite pegmatite, is right here. It's near it, but it's not directly touching the magma. And it looks like this. It looks a bit coarse with different colors, the main color being gray or white. That is granite pegmatite. Next, diabase. Diabase. Which is diabase? It's the one in the middle. The black one that looks like it has a lot of holes. This rock solidified from a basaltic magma within a few hundred meters of the surface, probably beneath a volcano. It is cooled rapidly, giving it a fine-grained, peppery appearance. The black mineral is pyroxene, and the white one is plagioclase. So, if you look at the rock closely, it has both black and white colors. It's at these two rocks right here, the granite pegmatite and the diabase, they are intrusive igneous rocks, which means they are formed inside, okay? They are formed inside the earth. That's diabase. And granite pegmatite. This diabase, it's actually formed at the bottom of a volcano. If you find rocks at the bottom of a volcano, you will see that they actually look like this. Now let's go to the next type of rock. Diorite. Okay, this type of rock is called a diorite. It looks a bit, it's a gray and white, and some parts are black. So where do you think diorite is formed? This rock crystallized in a mountain belt. It contains the minerals plagioclase, white, and hornblende black. Oh, this rock was created or crystallized in Iron Mountain Belt. It contains the minerals plagioclase white and hornblende black. This is also another example of an intrusive igneous rock. Now let me just stop the sharing here and let me just go back to the website and we will see where we can find more rocks to look at. Let me just go back a bit to the history of this. I hope you understood all about intrusive igneous rocks. The intrusive igneous rocks, they are found inside, okay? They are found inside the volcano or the ground. Now let's go here. The three types of rock, and then let's check the exhibit for the sedimentary rocks. We're already done with igneous. Let's go to the sedimentary rocks. And right here, right there, these things, these rocks, they are all sedimentary rocks. All of these are formed from what we call sediments. And what are sediments? Sediments are little parts of rocks and soil that are mixed together and pressed together in the form of a pressure point. These are all sedimentary rocks. Sedimentary rocks are layered. Some form when particles of rocks and minerals settle out of water or air. Others form when minerals precipitate directly out of water. Sedimentary rocks are identified by their minerals and their texture. As the sediments pile up, water is driven out by the weight of the overlying pile, and the minerals precipitate around the sediment particles, cementing them into rock. This process is called lithification. So basically what it means is when the rocks are formed, the sediments are formed because of the pressure, it pushes out water. And when it pushes out water, it will then, the rock particles, the sediments will then get more closer together. And then it will slowly harden over time in the process called lithification. So what are examples of sedimentary rocks? This is one of the most common sedimentary rocks. It looks a bit light and maybe a bit of brown or orange in there. This rock is called a limestone. Okay, this white rock is called a limestone. Limestone is one of the most widespread sedimentary rocks. Many organisms, from corals to microscopic foraminifera, grow shells composed of carbonates. Most limestones form when those organisms die and their carbonate shells accumulate in shallow seas. Oh, so a limestone is actually formed by different organisms. When they die, their bones, in a sense, become part of the limestone. Let's go to the next one, okay? The next one is this one. What do you think is this? It's a bit red or a bit orange, but I think if you saw it, it is what we call shale. Okay, this is a shale. Shale is made up of clay and slate, particles that are finer than sand. Clay and slate are deposited in slow-moving rivers at the far ends of deltas and in other quiet environments where slow-moving water cannot keep the particles suspended. Okay, so this area right here, this shale, it's actually made of clay. Yes, clay. Clay is like soft soil. And when it dries up, it becomes hard, like a rock. In fact, if a lot of clay and slate mix together, and they dry up because the water suddenly loses, or an area suddenly loses water, like if there is a drought where there is no rain for many weeks or days, an area might lose water, and this part will form. This is called a shale. And it's brown or orangey because that's the color of clay. Next, This one, this big example right here is called a sandstone. A sandstone, if you can guess, it's actually made of sand. That's why it's called a sandstone. Sandstone is made of sand which accumulates in rivers and along ocean shores where water moves fast enough to remove the finer particles. Sandstones can also be deposited by winds to form sand dunes. Okay, now, sandstones are made near rivers or lakes where water moves fast enough to remove the finer particles. It is made up of sand and other types of sediments. When it dries up, it becomes hard. It becomes a sandstone. But when you try and break it, it will be not as hard as other rocks because at the end of the day, it's still made of sand. And that's here. Let's go back. We're done with the igneous rocks and the sedimentary. Let's now go to the last one, to the metamorphic rocks. Okay, all of these right here, these three big pieces, except for the shale and the sandstone, because we know the shale and sandstone, they are not metamorphic, they are sediments. These ones right here, they are the metamorphics, metamorphic rocks. Metamorphic rocks form when sedimentary, igneous, or pre-existing metamorphic rocks are changed by heat, pressure, and chemically reactive waters. These rocks are identified by their minerals and texture. During metamorphism, new minerals grow with different sizes, shapes, and orientations than those of the original minerals. The chemical composition of the original rock may also change as some elements are carried away and others are added by the fluids flowing through the rocks. So what this means is metamorphic rocks are rocks formed when igneous or sedimentary rocks or even other metamorphic rocks are changed by heat, pressure, and even water that has a lot of chemicals. Now let's look at this one. This is a unique rock, right, class? It looks a bit rugged. Oh, this is a Manhattan schist. Originally a shell, this schist now consists of dark biotite-rich layers and finer grained light-colored layers made of gray quartz and white orthoclase. The distinct layering developed perpendicular to the direction of compression. This schist underlies most of Manhattan. That's why it's called Manhattan schist, because it's a rock found under a city in America. The name of the city is Manhattan. Originally, this was shale. Remember clay that got dried and became sedimentary rock? It was like this before, but because of the magma underneath it and the pressure of buildings, it slowly compressed and made itself into a Manhattan schist. Next, slate. Oh, this rock looks like it has a lot of markings. This slate was once a shale. Oh, another shale. Because the shale was metamorphed only slightly, texture changed little. It is widely used for roofing. Now, this type of rock, this shale, this slate that was once a shale, it's only heated only a little bit. That's why it has a different look from the other one. But it's still an example of a metamorphic rock. And other people, they actually use this as part of their houses, their roofs, because it's sturdy and it can stop the rain from coming in or the sun. Finally, we have this. This is what we call gneiss. Okay, that's how you read it. I think it's gneiss. This rock was once a granite, as it was deformed by heat and pressure. The original even-grained rock developed dark layers, primarily biotites, and light layers, mostly gray quartz, pink orthoclase, and black hornblende. This gneiss was once a granite, but again, because of heat and pressure, it changed into a different rock. That's the important thing you should understand. Metamorphic rocks, they change because of heat and pressure. And that's it for today. I hope you can understand more about the different types of rocks and what are they called. I will see you again next time. Goodbye.